So you can imagine.
Okay, good morning and welcome back. Since we have a reasonably tight schedule, I think I will get started. And we have 20 participants. Okay, nice. I think, yeah, so can you hear me well and see the screen? Yes? Nope? Should somebody respond in the chat? Okay, good. All right. So, um, so today and tomorrow, as you heard, we're going to see some set of miscellaneous topics. So what I'm going to talk about is the string matching problem in streaming model. And recall the string matching problem is you are given an input which is a text and the pattern P, and the question is, so P and P are some uh, strings in finite alphabet. So one. In particular, we're going to assume for this talk that T is a string of length n, and P is a string of length m, and what we are interested is find all occurrences of P in T. In particular, find positions in text of all occurrences of P in text. Right? So my text, again, I'm going to assume my sigma is just 1 to k or something, right? These are numbers. It's without loss of generality because if it's just some finite alphabet, give some numberings to the characters and your sigma is going to be some finite alphabet. Or okay. So for example, my text could be like this. And my pattern may be, then I want to find all occurrences of this 236 in this pattern, contiguous occurrences. So in this example, 236 does not appear at all, but if P is like 145, I see there are some two occurrences, and there could be um, overlapping occurrences, which I will count as separate occurrence. So for example, if T is 14213, okay, engineer something. If P is 1231, and I might have, then this is an occurrence, and this is another occurrence. All right. So you have presumably seen algorithms for this problem in your algorithms course. If not, please go take a look at Carmen's book or any other book. And some nice algorithms known. So a naive algorithm would take time, order m times n. Recall that m is the length of the pattern and n is the length of the text. So you can naively slide the pattern with the text looking for matches. And if there is a match or if there is no match, you just slide it by one step and keep doing it. So it could take order n times n, and is a very classical algorithm to Knuth, Morris and Pratt, which can actually solve this problem in order m plus n time. It's pretty much as good as you can do. So what this algorithm does is, sort of builds what is called a prefix function, or if you like, an automaton. You're used to this concept. It's more or less like an automaton for the pattern P. So takes the pattern, pre-processes it somehow, builds some sort of an automaton to accept all strings containing this pattern, and then you slide your text. Okay, so and then run the text on the automaton. And this, this takes order n time, and this takes order n time for the pre-processing to build this automaton. And then you're just running the text. So this is, once you have done this, this is really a real-time algorithm, because just once you see the next character of the text, you know which state to move on. And if you reach the final state, you know that the last m occurrences is form, pattern. So this is really a real-time algorithm. So in a sense, okay, if I want to slowly move towards a streaming model where we assume that the text is coming one at a time, and we want to be able to answer, does the last n characters of the text match the pattern? Then this actually answers in real time, in constant time. The problem is that this uses order m space. This corresponds to space because it's just going to either build this prefix function or automaton and keep it in your memory, and then it runs the text. So this takes order n space, but it's very efficient on the running time, even in the streaming model. However, the problem for us is the space. So our goal now is to try and improve the space requirement, maybe if necessary at the cost of increasing the per character time. So I'll actually formally tell you how the problem is in this model and so on. But let me just go with this classical models and algorithms for a while. Okay, so so there is another algorithm due to that main ideas are from Karp and Rabin, and that is the algorithm which is going to be the foundation for our streaming algorithm. That algorithm works like this. Okay, so if you think of your text as and if your pattern is, let's say this is your pattern, then think of this pattern as a number, okay, which means you actually compute 4 into 10 cubed plus 5 into 10 square plus 6 into 10 plus 7. So 4,567. This is like a one-time computation for the pattern. And compute this number, the first 4 digits again, and just check whether these two numbers are equal. If they are equal, the pattern matches that text with that alignment. And if not, the pattern does not. And then now you move your text to next alignment, which is this. Okay. Well, and compare your number with this new number. But this new number computation is not very hard because it's sort of incrementally, because I have already computed this number, 7,373. So subtract out 7,000, 7 into 1,000, and multiply by 10 and add 2. This is again an incremental constant time computation. And then compare these two numbers, whether they match or not, and keep going, right? So then you just go like this. So that would be pretty efficient order n time algorithm. And you just have to remember this number with you. Okay. Now, what is the problem with this algorithm? Let's not worry about space for now. Space is also an issue, but what else is a problem with this algorithm? So again, I think of my whole pattern as a big number and compare the pattern with the corresponding text and keep aligning, moving the alignment, and compute this new number at the text of the new alignment, which is a constant time operation, and keep going. And without worrying about the space, what is the problem with the time? What is the problem with this algorithm? Repeating characters, so what? No problem. Where is the problem? I didn't. Maybe the example I gave have no repeating characters, but absolutely no problem. What's the problem? Think of this as a number. Just compare these numbers. So it's an order n. Is it an order n algorithm? Space is one issue. I'll come to space later, but for now, let's look at the time issue. Is it a linear time algorithm? Anybody? If you don't understand the algorithm, put a -1. I can repeat it, and otherwise, just if you have any idea on the answer of my question, yes. Alphabet size can be large, so we may not be able to use base 10. Sure, okay. So use whatever base it is. If the alphabet is a size 100, use a 100 base number and do the same with your text and compare. That's one problem. So remember, we are working with big data, right? Suppose my pattern is 1,000-digit number and my text is 10 million size. My pattern is 10,000 size, let's say. Now I can do the same thing. There's no problem with the algorithm. I just treat this 10,000 digit thing as a number, compare this number with that number, and repeatedly find this new number and compare, keep comparing, and it's a linear time algorithm. What's the problem with this? Not a trick question. It's pretty easy question. Fatigue has set in, is it? Last day or almost the last day.
So the P may be too large, or the number of patterns may be too large to fit in memory, or T
Yeah.
may be too large. And if
Memory
all
is
these
one
things happen, then
memory is one thing, but is it reasonable to say that I can compare two 10,000 digit numbers in constant time?
yeah, yeah, that is also
Unreasonable. That
unreasonable.
if you are working with 64-bit arithmetic, even 128-bit arithmetic, okay, you are multiplying two numbers of that size in constant time, your CPU can do it. But a 10,000 digit number, I mean, a number value could be something like 10,000 digits means it may be 10 power 10,000. And is it reasonable to assume that you can multiply two such numbers or compare two such numbers in constant time? So it is unreasonable. So that's a problem. Okay. So for small patterns, this is fine. You can say it's constant time. You can do an order in time. I mean, you can compare, but that it is not reasonable to say that's constant time. Okay. So what we are going to do is something we have done several times in this course. Okay, so space is also an issue. Space is that you are remembering this whole pattern, which is too much because pattern is given to you in advance. I can't, anything you store is considered as a space. It's a stream, it's coming. You can only store something about the pattern. But, if you store the whole pattern, it is like order n space. And that's sort of what we are trying to avoid. Okay, so, so one thing what we will do is, okay, you complain that you are working with 128-bit arithmetic, and so 10,000 digit number is too much. So what we will do is we'll take this pattern, this huge number, and do mod some small n, okay? Or let's say n cubed. If n, because I said n is my text length, so I'm going to assume that I'm going to do mod n cubed. Take this whole number and compute it, mod n cubed. Now the number size has become, number value has become up to n cubed. So it's like a 3 log n bit number, which fits into our model of computation as a constant word. Now you can do the comparison and if the comparisons match, we say that it is the pattern matches, and if it doesn't, we know we'll claim that the pattern does not. What is the problem with this? Right now, I'm going to do everything in mod n cube computation. We'll see why n cube later. And so now I take this 4 digits also and compute, instead of it's not 4, p is going to be very large. I take this whole number, do a mod n cube, so the number has become something very small, and it's reasonable to say that it's a constant time, takes constant time to compare them. And then and in the mod n cubed world, the incremental number is also very easy because I just do the same thing, right? Subtract out 7 into this and add this, everything in the mod n cubed world, and compare it with this. And if the numbers match, I'm going to say it matches. If they don't, I'm going to say it does not. What is the problem with this?
So all of the let's say chunks of T we consider going to be unique mod n cube.
Sorry, I didn't hear you. Can you say it again?
For example, like we considered chunks of T, right? Like let's say, so they might not be unique mod n cube.
They might not be unique mod n cube. What do you mean unique?
Like
take the number, compute it mod n cube.
Right. So I mean, I'm saying like taking the mod n cube of 2 different numbers might yield the same result.
Exactly. That's exactly what Badri also has said, that these 2 numbers may be same mod n cube, but the actual numbers may not be same. So you wrongly conclude that your pattern exists in the text, seeing that these 2 numbers match in the mod n cubed world, but they don't. And of course, this is something we will be allowing it. And so that takes us to what kind of an algorithm it's called. We will settle for a Monte Carlo algorithm. Okay, so more formally, I'm not actually also going to multiply by 10 cubed. So here is my formal definition of a fingerprint. Okay. Fingerprint hierarchy of a string S. So let's say S is equal to S1, S2, some Sk. Then my fingerprint, so R, okay, so P is a prime number. And R, I'm going to choose random value in this field, FP, 0 to P minus 1. And once you have this pattern, I'm going to compute this number like exactly what I did before. So this is going to be S1 into not 10 power, but R power K minus 1 plus S2 into R power K minus 2 plus dot 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 plus Sk. So Sk minus 1 into R plus Sk. So it's a number. Everything mod P, of course. Okay, and P we will say is order n cubed. Remember, n is the length of the text. So I pick a prime number in the order n cubed, and I pick a random value in this field FP, and I'm going to compute this number S1. So it's exactly like what I did before. I took off it as number. Instead of decimal into 10, I'm going to do it over R power K minus 1 plus R power K minus 2, and the whole thing mod P. That's the number, and that is what I will be computing, comparing all the time with the pattern and the text and do the alignment. Now let's do some simple lemma. Let's get it out of the way, which is going to tell you something about your probabilistic error bounds, right? So here's my lemma. let S1, S2 be some string of length k, where k is less than or equal to n. And suppose these two strings are not equal, then let's see the probability that the fingerprints will be equal. You see that this will actually be the error probability, right? So what this is saying is that the two strings of length k less than or equal to n, the strings are not equal, but when I do these computation, they become equal. And if I bound this probability, that is exactly my error probability, because my algorithm will just compare the fingerprint and answer whether the string pattern exists or not. Okay, so this is what we have seen this several times. R is a random number, and this is, if you think of replace R by some X, we're talking about a polynomial, univariate polynomial of degree k minus 1 in a field of size n cubed. So this is equal to probability that okay, I could just, I don't want to introduce new notations and mess up with it, but can somebody tell me this, what this answer is? Well, if R, so these two strings are not equal, so you take the corresponding thing, subtract it out, and then multiply by R power k minus 1. All I care about is that what is the probability that R is a root of that polynomial, because the two strings are not equal, but when I plug in evaluate it R, this difference happens to be 0, which is same as asking what is the probability that R, which I randomly chose from FP, is a root of this polynomial. Well, this polynomial has how many roots? At most k distinct roots. So if I choose those, any of those k, that is the probability that I will make a mistake. So this is basically at most k by n cubed. But since k is at most n, this is at most 1 over n squared. So that means that with probability at least 1 minus 1 over n squared, if I compare the fingerprints and say, and make my decision based on that, I will be right with probability at least 1 minus 1 over n squared. Is it clear? Any questions? Put +1 if you follow it and ask questions otherwise, or put a -1 if you don't understand it. Good. So this is, this is something we have seen again and again several times. Just, simply think about polynomial of degree k as at most k roots in any field. So you choose your field size to be large enough, and you pick a random number, you can bound the error, right? So to start with, we think of these as numbers, and then we do the natural thing of modulo computation to go down to a small number where comparisons is reasonable. But then instead of evaluating a 10, I'm evaluating a random number R, and over the choices of R, I can control the probability of error. Okay, good. So now let's, so this is a starting point. Let's now carefully look at, in the streaming model, what happens to the space. What is happening? What are we storing? So of course we store the value of the pattern P in, you take the P fingerprint of P, which is a reasonably small number, which is a number in the field. So it's P, so that's just a log P number. Okay. But is that all? What else is the problem? Okay, remember, nothing else. Text is coming and going. Unless you store the characters, you're not, you don't know the characters, right? So let's carefully see what it takes to compute, actually to run this whole algorithm. So here is my text key, T1, T2, it's just coming, okay? So maybe there is TJ. And I have computed my fingerprint for the pattern, which is a small number. Computed. Now I am, let's say I evaluated, computed the fingerprint for the first, so the characters are coming. We have a problem at the first attempt itself, right? Because T1 is coming. What do?
We need to store the first M.
Exactly. You need to store not only the first M, you need to store every M characters, because so let's say I've stored this and I've compared it with my pattern, and then the next character is coming. I need to compute this fingerprint. Okay, so let's say this is T1, T2, Tk, and this is Tk plus 1. Then we already saw that the fingerprint of the string T2 to Tk plus 1 is the new fingerprint I need to compute. Well, can I compute it from my earlier fingerprint? Well, let's see. T1 to Tk, and you divide, we said we minus T1 into 10 power k minus 1 or something, plus Tk plus 1. This is what exactly it is, right? Take the fingerprint, all mod p, of course, and subtract out T1 into 10 power k minus 1, so that what I get is this. And then, I also need to multiply by, sorry, I shouldn't say R, 10. We are doing it with R, right? So this is R. And then multiply by R, this whole thing, and then add Tk plus 1. That is the new fingerprint. So R are something which I can always keep. That's not a problem. R power k minus 1, I can compute and keep it all the time, or m minus 1. So I have the fingerprint of this, but I need T1, which is the problem, right? Tk plus 1 is coming, but I need T1. And the same problem. Next time when I go to do, I need T2, I need T3. So in particular, you need the M characters of the text, which you should remember. Apart from the fingerprint for the pattern, you actually need the M characters of the text, so that you know what to subtract out every step. You have the fingerprint value of whatever you've seen so far, but you need this to subtract out. This is coming in. Okay. So more importantly, you need to store last M characters of text. So that's order n space. Okay, we have a randomization already, because we are doing this fingerprint computation. So there is some error. This is a Monte Carlo algorithm. It does not, if it says no, you can definitely believe it. It's only one-sided error. But if it says yes, it may be wrong with some error, and we can control the error probability. But the other bigger problem which we need to worry about in the big data world is that it uses order n space. So what I want to tell you in the next about 20 minutes or so, an algorithm, or at least give you an overview of an algorithm which improves the space to order log n. Okay, so this was but at the cost of increasing the time. So you remember, the time wise, this is very good, because we have this fingerprint. It is just a question of subtracting out. If you know that all this T1, You multiply it by this. This is just one computation. Subtract it out. Add, multiply by r. Do a mod p. All of this is like a constant time, and then do a comparison of these two numbers. This is a constant time operation, but space is order m. So what we are going to do? So this is an algorithm due to Red Fox 2009. They gave an order log m space and log m time. And when we say time, it means it's time per character. So a new character of the text that comes, then I'm going to spend some log m time to say, report all the matches up to that point. Okay, and this is actually improved by this law. And Galil. This is a CPM 2011, and it is in transaction algorithms 2014. And they improved it to again for the log n space and constant time. Of course, both are randomized. They actually build on the same fingerprinting ideas. So it's both randomized. And it's not even clear that deterministically you can improve order n space. Yeah. So I'm not completely sure, but I think we cannot. I don't know whether there are some lower bounds. Okay. So what? So these people also simplified this log m space, log m time algorithm. So that's the version I'm going to talk about, and we'll get started on that. So any questions? Okay. So what this is going to do is that we're going to think of some log m levels of information. Okay. And I'm going to, so let's say, look at the prefixes of the pattern. So my pattern is P, so I'm going to say P0 is just P1, P1 is P1, P2, P2 is P1, P2, P3, P4, and in general, P log m is, true to the log m. And then the last one would be the full pattern. This P may not be the multiple, m may not be a power of 2. So these are prefixes of the pattern of length, this appropriate length. Okay. So at any point of time, so my text is coming at any point of time, I'll tell you what we store, and then the problem boils down to how we update this information when a new character comes. At any point of time, for I going from 0 to log m, I'm going to store this vi, which may have more things. Okay, so let's say ni This is all my notation, not necessarily in the paper. So I'm going to store 3 information for every I. So that's going to be like 3 log m information. Okay. No, sorry, not 3 information. It's a whole set. So where, what is this J? Okay, so TJ. Yeah. Okay, let me just finish this and then I'll come back. Okay, so TJ plus 1 up to T2 power I matches P2 power I. So let me say this pictorially so it's easy to understand. So what I'm going to have is there is V0, there is V1, V log M, and here is my running text. So here is a text which is coming. Right? So V0 is going to have all positions of the text, that's the J, which match with P0, P1, the first character of it. So my P1, these are all the positions, these are all this J, where it matches with P1. This character matches with P1, this character matches with P1. Okay, let me also qualify it as, but not yet with P2 power I plus 1. These are characters which match with P1 but not yet with P2. So you'll see that actually you cannot have too many, even though I've drawn this, it's sort of misleading. So V1 will say, okay, these are the positions which match P1, P2. These are the positions which match P1, P2. And then, and so on, right? But not yet with substring of prefix of length 4. Okay? So at the text, so all I'm saying is, I'm going to look at what are the positions that match P1, P1, P2, P1, P2, P3, P4, and so on, but not yet. Not yet means what? It is a viable starting point to match with the next prefix. Okay, I have not ruled it out. That the reason I'm not ruled it out is because I have not seen so many more extra characters yet. Okay, so that is J, and I keep the fingerprint from T1 to that position. We ignore NI for the moment. So I keep the position and the fingerprint up to that point. Those are the two things I'm going to remember at level I. And this position J means that starting at position J, I match P 2 power I, but not yet. It's a potential match for 2 power I plus 1 because I have not yet seen that many extra characters to realize that this matches the next 2 power I suffix of the prefix or pattern or not. Okay, so yeah, maybe it looks notation heavy, but it's not very hard. Is there any question? Please ask. I will explain again. Because suddenly I will say the algorithm is over. Okay, because all we need to do is to say how to update this information when a new character comes, and then I have to argue the time and space and all these bounds. Okay, so essentially, in my text which I have seen so far, all I remember is what are the positions that match some prefixes of the pattern at 2 power I lengths, and they are potential to match to the next set of prefixes. Okay, and then I will tell you how to update it when a new character comes, this whole information. And then I have to argue the space and time for this information. Okay. So there are log m many kind of information I'm storing. I will argue that this set sizes are constant. Even though it looks like a triple of various things, there cannot be too many such positions, I will argue. Or if they do, there is a better way of representing them. And so this information takes constant space. There are log m many levels, so totally order log m space. That's the whole bound for the space. The time I'm going to say when a new character comes, I will tell you how to update each of these level information, and that's going to take me log m time. Okay. Okay. So what is my output? Well, output is all positions that match P1 to PM, right? All positions that match P1 to PM is my output. Okay. So this is sort of the invariant I keep, that at every level, which are the positions, I mean, for each of this prefix, which are the positions that match this and have the potential to match to the next level prefix. Okay. And so, yeah, okay, fine. So now you will actually see that how to update this information. I tell you how to update this information, and then we will. Okay. So now, so I have my text T, T1, T2, and so on, and suddenly a new text is coming. Okay. So what are the things I need to do, right? Compare P1 with PK, and if they match, add K and PRP P1 to TK to what? Can somebody tell me? I have to add it to which level? Have we lost everyone? So here is my level difference information, right? V0 contains all positions that match P1 and could potentially match to P2, P1, P2. Okay. So now I have P1 matches with TK. So I will add it to V0, right? The set V0. So this is a position which could be a starting point for a new occurrence of the pattern P1. So I add that and I add this entire fingerprint. See, always I keep, so what I'm keeping is the entire fingerprint from T1 to appropriate positions. I'll tell you why it is useful. Okay. Okay, if it doesn't, then it doesn't get into V0. But now I have to check whether, look at all positions which have matched P1 and see. So suppose there was a P1 match. This was in V1. No, suppose this was in V0. What does that mean? That this matched with the first character of the pattern. So then I compare the second character of the pattern with this, and if they match, then I promote this guy from V0 to V1 because I know that this matches two characters of the prefix. So I will remove it from V0 and move it to V2. Is that clear? Okay. But the problem is, I didn't know this character. How do I figure out this character? Because now I'm saying, so here is an element which was in V0, which means that I know it matched P1. Okay, I know it matched P1, so I know that, and I compare it with it. So at any point of time, I have, let's say, This was a position which matched 2 power I characters, and so this was in VI. Now these characters have come and gone. I don't know. Now I realize that this length, now the new character comes and this length is 2 power I. So I want to see whether I can promote this to VI plus 1 or drop it, right? So if this whole thing, after this new character comes, I know the length, which is 2 power I plus 1. So I will check whether this entire thing matches my P2 power I plus 1. If it does, I will promote this to I plus 1. And if it doesn't, I will actually drop it from VI also, because remember, this is not, this is no way I'm going to extend this to a match, because it's not matching in this position. So at this point, I will make this decision. If this length has become 2 power I, this is not, does not, then I'll just ignore and move on to the next level, right? I look at any level where this new character makes me, enables me to check whether this new thing matches the next level prefix. If so, if it does match, I will promote it to the next level, delete it from here. And if it doesn't match, I delete it from here permanently. It doesn't get it anywhere. So this position is out of the set, because even though it matches these 2 power I characters, it is, it's not, there is no hope of making it to my entire, matching to the entire string. The question is, how do I know this? How will I figure the, these characters, because I have lost them, I didn't store them. Okay, but here is the beauty, right? So I know the fingerprint at this point, because I've stored that from T1 to here. And I know the fingerprint at this point. I know this fingerprint. I know the fingerprint up to this point, because this is a running fingerprint I keep computing. Now from these two fingerprints, you can compute this, because this is another lemma which I should have said. Maybe let me say it here. Observation, fingerprint are key of Q R fingerprint is R key. Okay, let me see. V can be computed from fingerprint of UV and fingerprint of U, because it is just this algebraic expression. I know what this number is, summation blah 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 r power k minus 1, all that, this whole thing, and I know this. So from that I can compute this, because it's just again some multiplying by r power some number of one of them and adding something and so on, because we know this. Okay, so is this observation clear? Put +1 if you agree, otherwise I'll explain again. Okay, so 1 + 1, others are given up. Okay, few more. So all I'm saying is fingerprint is of this specific linear, polynomial evaluated at R, we know. So if I know this, and if I know this, I can compute fingerprint P. So that's exactly what is happening here in my previous slide. What I said is that I have kept this fingerprint. That's what, because fingerprint at all these little positions I've stored, and I know that it matches 2 power I characters. That's why I made into VI. Now I let these characters pass by until this becomes another 2 power I. So that's 2 power I plus 1. At this point, I will see whether this whole thing, based on the fingerprint of this, I know the fingerprint of this, I know the fingerprint of this, so I can figure out the fingerprint of this whole thing, whether it matches my next prefix. If so, it gets promoted to the next level. If not, this gets thrown out of my entire prefix. And this is the update step I do at when every character comes. I have a constant time operation on each of this level to see whether it can be promoted to the next level or thrown out, based on these fingerprints and comparing with the next level fingerprints. So that's order log m time for each character. And ultimately, what will I output? All that positions in V log n is exactly those positions which match from that position all the way up to M matches PM, and this is my output. So whenever I know, for example, whenever I see that somebody here can be promoted to the next level, what does that mean? I have matched the whole pattern, so I will output that position. Okay, so the only thing now I need to argue, I'll try and do in next 5 minutes, is that space usage is order log n. And so this is the time. Space is order log m, again by arguing that I have only constant amount of information that's stored at every level. If I argue that, that will be order log n. Well, what am I storing? I'm storing all positions from which that are matched pi and potential to match pi plus 1 and their fingerprints. This is a constant information. And this, I'll say something about the NI. Now, what is the problem if, let's say that there are more than, no, I want to argue that if there are 2 occurrences of these P2Is at every level, I am fine. But if there are more than 3, what am I going to say? So then, if the number of occurrences is very large, isn't that a problem to store in the set? And there is a nice little lemma which tells that it can be dealt. So what is the problem? So I have this text. And suppose some pi occurs from here, some pi occurs from here, the same pi, and some pi occurs from here. It's the same pi, right? Because that's what means by 3 occurrences of the 3 positions in which pi is matching and potential to match pi plus 1. What does that mean? That means that these characters are the same as these characters, which are the same as these characters. Okay. If this happens, there is a little lemma which tells the following, that you can somehow deterministically figure out this gaps, because there is some periodicity that's happening. So what are the gaps at which these PIs happen. So you don't need to remember them at all. You just remember the first and the last and the periodicity, and then you know that all these positions, this set VI, can be compactly represented by remembering some 2 or 3 numbers. Okay, so let me just write down this lemma and we more or less will end because we try Pran. So this lemma is so suppose you have this, okay, let me draw this pictorially. So here is V, and suppose some U occurs 3 times here. They may be overlapping. So let T1 less than T2 less than blah, blah, blah. TH be locations of occurrences of U and V, and suppose Ti plus 2 minus Ti plus, and H is greater than or equal to 3. So there are 3 occurrences, and Ti plus 2 minus Ti is less than or equal to cardinality of U. Then Okay, let me write. Then d, there is a constant ti plus 1 minus ti equal to d is the periodicity of u. Okay. Periodicity is a term which I have been trying to avoid, postpone till the last minute. What this says is that if you have 3 occurrences of a pattern, a prefix of the pattern, whatever in this case, in a text, then there is certain pattern in which these positions are, that the differences can be a fixed length. So, okay, that's what this lemma says. Okay, so for example, if you have, let's say, A, B, C, A, B, C, A, B, C, A, B, C, and if this is my pattern, okay, then the pattern occurs 3 times here. So this here is a pattern. This pattern occurs 3 times. Then the starting positions of the pattern occur at the same distance. So, from 3 characters here, this 3 characters, this 3 characters are the starting positions. And this difference is actually the periodicity of the pattern. Periodicity is the smallest substring which sort of repeats. Okay, I mean, it's not a formal definition. I don't want to get into it because I'm close to my time. But essentially, what this says is that if the number of occurrences of my pi is greater than or equal to 3 in my text, it can be compactly represented in constant space. Basically represent the first occurrence, the difference, and the last occurrence. Something, that's it. Okay. And you can figure out all of it because of this lemma. So what did we achieve? So at each level, you are representing only constant number of values. So this ni actually represents number of occurrences. Number of occurrences of this pi in your up to this text is what ni is. And you store all the positions and the fingerprint. Now, if the number of occurrences is more than 3, you don't need to store all the positions. Then you just represent the first and the last. Oops. Inadvertently, there is a poll. I don't know who pressed what. All right. So this means, to summarize, we have constant space for each level. So overall, we have log m space and log m time is what I set out to achieve. Okay. So what I've hopefully given you a very high level idea. What I did not necessarily tell you is the proof of this little lemma, which seems very, bread and butter in the stringology literature. So it's something independent of this whole string matching problem. It simply says that if there are these overlapping occurrences, there is some careful pattern in which you can predict the differences. So this whole promotion and moving things can also be done with this compact representation of VR. So whenever a new character comes, if it creates a new occurrence in that level, then you throw away one occurrence, keep only the last occurrence, things like that. Okay. And the error accumulation is not much. Okay, there's one little caveat on the error. One is when the fingerprints match, we say they match. So that is one cause of error. The other cause of error is this periodicity, right? When we, when we say that there are 3 occurrences of the pattern here, well, we are concluding that by just looking at the fingerprints, not necessarily by looking at the pattern. So that causes a bit of an error, but it's still one-sided error that whenever I say the pattern does not occur, I always am correct. And if it says it occurs, it is just based on the fingerprint. So there is some 1 over n square or some probability there. Okay. So What else is known? There is algorithms to compute periodicity. There is some work on approximate string matching. Checking for palindromes. In fact, this is not very hard in the streaming model, but in the property testing model, which you will hear about tomorrow. Yeah, so these are some of the work that is known in the literature on stringology in these restricted models. Okay. I will stop here. Are there any questions? Otherwise, we will have a short break and resume at 12:15. So, are there any questions?
So,
Yeah.
we're storing the fingerprint in every level, right?
Yes.
So wouldn't the fingerprint itself take log m space?
No, fingerprint is a number, one number. So what I store is the fingerprint of T1 to Tj. It's cumulative fingerprint, one fingerprint for every position. But fingerprint is what? It's just a modulo P number, right? Because you do this polynomials and then take a mod P and that's just a number. So, okay, one thing if maybe could be a point of confusion, when I say space, it's actually some order log n bit word. So we are not counting bits. So if you want to count in bits, it's log n times log n bits.
Okay, sir.
When I say
Thank you.
space, it's a register, it's a number, how many log n bit words? Because fingerprint is just a number in the range 1 to n cubed, because P is our n cubed. So I've given references for these papers. You can in fact, this is a more accessible. I mean, yeah, both are reasonable. Okay. This is Transactions and Algorithms 2014 and 15. I forget. All right. Thank you. Then we will resume at 12:15. There are no more questions.
Hi, Amit. Hello.
Hello.
Would you like to
Hi,
share
Saket.
your Hi, yeah. So are you planning to use slides or something?
Yes.
So would you like to share your slides?
Okay. Are you able to see them?
Yes, I'm able. But so it is still coming with all the controls. So maybe okay, probably have to do slides or something. Yeah, it's good. So let's
Okay.
wait for a couple of minutes. Generally, some people would arrive a bit late.
Okay.
So let me start introducing our next speaker. Our next speaker is Amit Sharma. He works at Microsoft Research India, and he's going to talk about very important and interesting topic today called Moments of Change, Technology for Supporting Our Mental Health. So it's a combination of computer science and health. So, and how, what do you call, machine learning and big data comes into this area of work, and how naturally these things are. So you will get a first-hand opportunity to hear and listen to one of the practitioners of the field. So with this, I would request Amit to start his lecture or talk for all of you. Amit, over to you.
Thank you, Saket. Yeah, it's my pleasure to talk at this winter school. As Saket said, I work at Microsoft Research. We are a lab in Bangalore, and our lab looks at different ways and research questions of computer science. But one particularly that's of importance is the question of how technology can be useful for the unique challenges that India faces today. And I'll talk about one such challenge that I work on. This is mental health. And one of the things that I should say at the beginning is that my training is in computer science, I think, like many of you. Uh, so I don't think that I am an expert when I talk about mental health. But what I'll try to give you a flavor of is how, by communicating and talking to domain experts from other fields, in this case, I work with clinical psychologists and mental health professionals. You can learn from them to abstract out what may be the computer science problems and then make your contributions accordingly. At any point of time, if you have questions, I don't know how to do that, Saket. Can people just speak up?
They can just unmute and they can speak up, or they can ask a question in the chat. So I will moderate it if there is something asked in chat. But I would just say that they should just unmute yourself them and ask question, because that is the format we have followed. Because at the end of the day, it's a school.
Yeah, I think that's best because that way it's interactive.
Yes,
So yeah,
right.
everyone just feel free to speak up, and I can answer questions during the talk. All right. So with that introduction, uh, I'll talk about first just a broad introduction to mental health, what kinds of challenges are unique to India, and then how technology can help in this very complex issue. So, as the World Health Organization describes mental health as a state of well being in which every individual realizes his or her potential. And as you can see, this definition is very broad, right? So, it's not about a specific kind of condition or ailment. mental health really is unique among different types of or different sort of classifications of health, in that it covers not just a particular biological condition, but the whole capability of a person to realize their potential. So this would mean if you're a student, like how are you functioning as a student, and are your environment and your sort of feelings and emotions consistent with what sort of would make you a productive person in that field. And mental illness then is the other side. So mental health, you can think of it more as wellness that allows you to reach your potential. Yep. And mental illness is on the other side, where people develop conditions where they are unable to realize whatever sort of tasks or potential they might have. So for example, depression and anxiety are one of the two most common ailments in the world. In the US, for example, depression affects more than 13%, more than 20% in the US, and more than 13% of the Indian adult population claim and are self-reported to have depression. And worldwide, there are over 350 million people who may be suffering from depression. One of the alarming statistics that also comes from WHO is that by 2030, it may be the #1 cause of disease burden worldwide, which means that it'll surpass heart disease today, which is the #1. Now, with that grim background, the other thing that's very alarming about mental health is that it's not that some countries have figured it out. So there are studies that show that even in rich countries like US, Europe, only 20% of adults actually receive some kind of treatment. And similarly, in the global south, which are more low and middle income countries like India, I guess many of you may be already aware from your experience that it's really bad, right? So first of all, there's stigma. So people don't actually speak up, even when they're suffering. And second, that about treatment facilities are really bad, right? And so the conclusion of all this is that if you have certain mental health conditions, and if you're living in India, your chances of getting treatment are very dire. And our president once said that India is facing a possible mental health epidemic. So in that background, there are two ways to look at it. So one is that it is true that this is a dire situation. And it's also more worrying that it's not talked about as much as it should be, given the scale of the problem. But at the other hand, it's also an opportunity to reimagine the mental health care ecosystem in the sense that since in many cities outside the top cities in India, almost nothing exists in terms of mental health care infrastructure. How do we redesign that today, given the technology and the know-how that we have from a technological point of view? One thing we have to be careful with, of course, is that it's a very complex problem. So we have to be socially aware. We also have to be culturally aware, and probably also community driven in how we address this problem. So it's not just about sort of, hey, I have some great technology, let's see how it can be applied. In fields like these, I think you have to be a computer scientist, but then you also have to have knowledge about the cultural norms and also how community functions to make something work. So here's a quick primer to the different mental health conditions that are typically diagnosed and that are also quite common in today's world. So at the top, you can see a well-functioning individual. Almost all of us have worries, lack of energy, fatigue on some days, and then other days they go away. And so if you look at the top, this is the set of people. This is basically everyone, right? So people are going through these different kinds of emotions off and on. But as you go down, what starts happening is that these kinds of distress emotions start taking up more and more of your time and your experience. And that's when people say that early treatment is useful. So at the top, you have mental well-being. There's no distress. When sort of these things are getting more attenuated, then you would want to start thinking of treatment or some kind of therapy that can be useful. And as you can see, as the person goes more towards the bottom of this figure, these are sort of specific mental health syndromes that can be diagnosed by a clinical psychologist or a psychiatrist. So you may have sort of the first bucket, which is anxiety, which is more connected to panic and avoidance. You may have mood syndromes, depression, and in severe cases, also psychosis. So with that introduction, you can start thinking that, first of all, it's not something that you can imagine can be solved by one machine learning algorithm or one sort of technology that you can deploy in a hospital, right? If you just look at it, I think you'll realize that it's much more multi-pronged than that. And one of the things that has happened is that in different stages, different kinds of interventions have been shown to work. So at the top, peer support tends to be one of the best ways to address people's distress. So this could be as simple as talking to a friend, or it could be sort of a more institutionalized way of connecting you to anonymous peers and sort of sharing what you're going through. In the second step, we have semi-trained counselors or phone helplines. So ideally, peer counselors can sort of only help so much, but then one of the best innovations that has come up in the world in mental health is that you don't always need a doctor, or you don't always need someone who's a clinical psychiatrist to converse with a person and sort of help them. In early stages, I think even with basic training, semi-trained counselors and phone helplines can help. So you can think of them in the health world, if you're aware of community health workers like ASHA workers in India. This is the alternate of that in mental health. And then finally, of course, we have clinical psychologists or psychiatrists. These are needed, and I think these are the sort of main experts here. But what India has evolved, and I think many countries have evolved, is a system that sort of has all three working. And this is what I'm showing you as examples here. So peer support today is with friends, but also online. So just like Facebook, there are communities, Talk Life and 7 Cups of Tea, that provide peer support to anyone. So you can be a user who joins anonymously, you share what you're going through, and other people come and support you. Similarly, there are phone helplines. In India, we maintain a repository of all phone helplines on this website that you can see, ineedhelpnow.in. And these helplines help people in times of crisis or sometimes in lieu of therapy. So if you're in a small town and you have no access to therapy, often people call these helplines, which are available. And then finally, this is more relevant to a technical audience, is that there are now apps coming up. So I've just mentioned two that are built out of India, Inner Hour and Visa. And these apps are trying to simulate what sort of happens in therapy with some simple self-help techniques that people can use. In this talk, I'll try to give you a flavor of how technology can amplify these support systems. So in part one, we'll talk about peer support. And if there are people already going online and talking about their feelings, being vulnerable there, how can machine learning augment their experience so that they get better help online? In the second part, I'll talk about the sort of hard problem of stigma, because we have to remember that there are some people going online, but for every one person who goes online, self-expresses themselves, knows about things like depression, there are many others who don't even probably know what they're going through, or they don't feel that what they're going through is sort of something that is common and something that can be taken help for. And so in the second part, we'll talk about this kind of catch-22 situation, that if someone is struggling, but they don't know the right resources, or they don't even know the right thought process to sort of find help, then can we actually reach them and help? And then finally, if time permits, we'll talk a little bit about India's phone helpline systems. This is also a project that we're working on, and just seeing how the current helplines can become more technological savvy and sort of help more people with the same helplines. With that background, are there any questions at this point? Okay. So I'll go to the next part where we'll talk about these projects. And one thing, I think the main point of this talk is that here we'll try to amplify the existing support systems. Our goal is not to build a new AI bot that can probably talk to people and kind of solve mental health, right? So I think that's maybe my number one message is that when you're working in fields outside of computer science, you have to be humble and sort of understand what are the present solutions, and then if they're good, then how do we try to amplify them? If they're not good, how do we try to sort of reduce uh, the the damage that they're doing and try to build? It's very rarely the case that you can just come up with something on your own and have it work in the sort of complex socio-technical systems that we build. And that's the summary expressed here as well. Technology is best when it's connecting people to existing resources. So we'll look at how technology can be used to connect people to mental health resources as well as mental health experts. And as a computer scientist, I think of my role as empowering the mental health organizations that are already doing good work. All right. So the first part, we'll look at how data and machine learning can help in this ecosystem. If you're not familiar, I'm just giving examples of two websites, but this is now a very popular phenomenon where people go online anonymously often and share some of their most private and vulnerable feelings, what they're experiencing, going through, and then magically other people on the internet who may not know this person actually come and respond. So this whole idea is bound by the strong sense of community where a lot of young people are helping each other, and in some way it's good because only sort of in some sense many topics can only be answered by your peers of a similar age group, of a similar background, and so on. And so this is really good, but it's all not that golden. So let me give you some examples of typical interactions that happen on these kinds of websites. So the first person, let's call them a seeker. They say that they're being overwhelmed. There's a responder who comes and sort of tries to give them some simple reflection techniques, and then they also give them some suggestions. And so this person says that this is great, I hadn't thought of it, and this helped them, right? So this is the kind of ideal interaction that you would want. But at the same time, this is an online social network, right? So what do you expect? So other times when, in this case, a person is talking about suicide, and the response that comes is actually a bad joke on that. And so what we really want on these systems is that the first kind of conversations should prevail, and somehow there should be less of the second kind of conversation. And there are more sort of sad cases on these kinds of websites where someone expresses themselves, says what they're going through, but then nobody responds. So it's just completely blank. And perhaps it sort of reinforces the sort of bad feelings that a person might be having about being alone, and so on, right? So we don't want the things on the right, and what do we do about that? So we worked with this organization called TalkLife. This is a company that runs one of these online social networks. And our goal with them was to first see if we can use data to identify the problematic conversations. And second, if we can use the user level data to see what responses can be effective. So we took data from these websites, and we had data from about 3.2 million posts and 25 million responses. And this was data for everyone who joined after 2016. Just a second, I'll be moving. And in this work, we were looking at what kinds of conversations and users, as I said, are more connected to good responses. So the hard question in here is, how do you define what's an effective conversation? One thing could be that you say it's positive, and you can say that the change that happens in a particular user's response is a positive cognitive change. So for example, you may have variance nuance definitions in clinical psychology. They're often measured using a qualitative scale, and it's hard to capture from text data. And when we came in, we saw that if we rely on the really true definition, it may be very difficult. And therefore, a better way of doing this would be to rely on something simple that we can develop. But then what we do is that we try to see how much does this simple metric that we have correspond to the real value that we want to establish. So that's what we did here. While we do realize that characterizing what may be useful to a person is really hard, we said that let's start with something simple. So let's say that if you observe a change in sentiment for a seeker on a topic that they initially talked about, that's a moment of positive change. Right? So in some sense, we have abstracted out this problem from a psychological concept to now a change in sentiment. And today, natural language processing is good enough that you can actually detect change in sentiment using text. And the way we tried to detect whether this was working or not was that we also collected data from anonymous crowdsourced workers on whether when we detected that there was a moment of change, whether people also thought the sentiment increased. So here, for example, you can see that this is one of the texts that we showed to anonymous annotators, and their task was to label the sentiment, whether it has an increase or not. And what we found was that about 80% of the conversations can be identified by something simple, like not even natural language processing, but sort of just labeling the conversations if they had some explicit expressions. I'm giving some examples here. So someone might say, thanks, I feel better now. Or they might say things like, hey, you have a point. So this is useful. So one thing to note here is that these expressions would be high precision, right? Because if someone says that, more often than not, they did feel better, but they won't be high recall. So that's something to keep in mind. So in some sense, we'll get a lot of conversations where people felt better, but that may not mean that we are getting all kinds of good conversations. Once that was done, we could imagine building a machine learning model where we have these labels of two types, right? One type is where people actually self-reported that they felt well, and the other was these labeled data. And then we did a 50-50 split between moments of change and non-moments of change threads. So this is standard machine learning. If you're already had lectures about building predictive models, that's what we are doing here. We have labels now based on the text that I just showed you. And then now we want to find out the features that lead to positive conversations. The specific features we used are from both the psychology literature as well as NLP. So from the psychological literature, we took linguistic inquiry and word count based features. And for the others, we used mental health based features, which were used in NLP before. So think of them like n-grams for specific words like anxiety, depression, suicide, and other concepts. And the model that we used, we tried a bunch, but I think I'll just describe gradient boosted trees. So the model here was pretty standard. We found some impressive results. So you can detect conversations with moments of change with high accuracy. So for example, the language used by responders is most predictive of a moment of change. This was slightly counterintuitive, right? So if you think about detecting a positive change in a seeker's sentiment, it turns out that it's not important to look at what the seeker is saying, but it's important to look at what the responder is saying. And post hoc, that kind of made sense, right? Because the change has to be brought about only by what the responder can say. And so that's what we find in our machine learning model as well. And then words related to sentiment, affect, intimacy, and mental health language were important. But the important thing is here that we were able to detect with 88% accuracy on whether a particular conversation will be useful or not. And one way you can imagine this is great is because now TalkLife can predict in advance on which conversations would be beneficial, or at least after a conversation has happened, maybe every day, they can look at the current conversations and say which ones have been good, which automatically means they have now data upon which conversations are not going well. And maybe that's where they can send their most experienced responders. But hang on a minute. We are getting ahead of ourselves because it's not clear that we have kind of solved this problem, right? So one thing that we tried to do was some kind of basic sanity checks on our model. So one immediate thing you can imagine is that there are multiple users from different countries. What if we train our model on data from India and test our model on data from non-Indian conversations? Similarly, you can imagine the reverse, where you can train on everyone from outside India and then test on Indians. So here's what we find. If you're training and testing on the same population, we get similar high accuracies. But as soon as you generalize your model to a different country, our accuracy decreases. And in one case, it's about 0.68, which is really low compared to 88 earlier. And so this tells us two things. One is that context matters. It means that people in India may be expressing their feelings differently, and people outside may be expressing differently. And it's probably not going to be the case that the same model is going to work for everyone. The second thing, which is more worrying, is that it also is showing that our model is only capturing the surface level features, right? So in a sense, it's just sort of capturing some kinds of words or some kinds of features that are connected to emotions, but they're not really capturing the real change in emotion itself, right? Because if they were, then they should have generalized much better than what we see. And if you want to think more deeply about this, you can also think of in terms of causal influence. So it's usually tricky to differentiate causes between positive cognitive change versus just correlated features. So here's an example that I'm showing you. Imagine that you had two people and you got some responses. And in one case, the cognitive change was negative. In one case, it was positive, right? What may be happening is that the responses are causing the cognitive change, and that would be the world one. But it's also likely that there is just some baseline confounders or baseline prior knowledge about the seeker that is also leading to cognitive change, right? So maybe what's happening is something people when people post about, let's say, academics, there's a higher chance that they'll have a positive cognitive change, perhaps because their exam gets over or some other thing happens. But maybe when people talk about relationships or when they talk about some other topics, it's very hard to get a cognitive change. And so this is something that I want you to keep in mind, is that even though we are using machine learning models to predict, we have to be careful to check whether their features are what we think should be, right? So we have to be careful to check whether the features they're capturing also capture the processes by which cognitive change happens. So we've done other work, which I'll not talk about in detail, but just give you a flavor of what do you do when you think that there is a machine learning model that works, but maybe it's not capturing the causal features. Maybe it's just capturing some correlations. So what you can do is you can use methods from, again, borrowed from medicine and epidemiology, where you're trying to find same features again, but now you do a much better controlling. So earlier we were just looking at, hey, here's some people who had a positive change. Here's some people who did not have a positive change. Let's just try to find which features are different between them. You can just do the same analysis in a more careful way, where now we'll still have people who had positive change and people who did not have positive change, but we'll try to only match those people who had similar backgrounds and who were talking about similar topics. That's the basic idea. You can do it on much broader and much sort of specific variables as well, but for the purpose of understanding, just think of it in a way that we're just controlling people and matching people with similar topics and similar backgrounds. And so therefore, now if you see a change in feature between someone who got a positive change and not, then you can say, okay, that has to be because of the response, or that has to be because of the activity that we are seeing. And when you do that, you find that it becomes much more interesting. So first of all, obvious things like immediacy of response or the emotions that are used by the responder actually don't have that much of an effect. So if you look on the left, I'm showing you a plot where there's a treatment difference between case and control, which means how much was this feature useful for improving a person's mental health. And on the x-axis, I'm showing the different features. And here you see that the most important features actually turn out to be complex linguistic features. So topical congruence means whether the response was on topic or not. Linguistic accommodation means that whether the style of English used by the responder was matching to what the original seeker had said. And this perhaps, again, you can think of is pointing to something more deeper, which was perhaps whether the person was empathizing with the seeker's response. And so with these, we had a much better idea of what was really helping. So it was not just a matter of responding quickly or a matter of just having some positive looking information. It was more a matter of adapting and being on topic to what the person was worried about. And here, I think one thing you can imagine is that this is wonderful, and we probably should now think about how you can implement this on a website like TalkLife. Here, we are still working with them, but I think one of the challenges we are facing is that TalkLife asks questions like, how good is this model on different kinds of data? So I just give you a simple example about India and rest of India. You can also imagine many different ways of comparing people and whether the model is good for older people versus younger people, whether the model is good for Europe versus India. And so there are lots of questions that we still have to work on before this could be something that we would be comfortable deploying at a large scale. Because I think the second thing that we have to think about, like, one, this is very exciting, and we have used machine learning to understand mental health better. But on the other hand, once the model is deployed, it's going to affect people's interactions on that platform. So we have to get much better data on how it's going to be impacting that. So that's the first part of the talk. If there are any questions, I'd welcome them at this point.
Oh, I have a question.
Sure.
Yeah. So the data set that we are talking about over here is the data set from TalkLife, right?
Yes.
So every data point in this data set is basically someone talking to a counselor, and that counselor replying, or someone on the website having a conversation, right?
Yes. Yes.
Okay. So I mean, don't you think that by virtue of going to such a website, the conversation is colored? For example, if I'm talking to you as a friend, Amit, who is my friend, maybe I'll be, or say, I mean, maybe by going to a website like this, you want to talk like this, or maybe you are forced to talk in a way so that you gain attention, or you gain empathy, or you want someone to notice you.
Yeah.
So I mean, don't you think that the data set in itself is colored? I mean,
yeah, I think it's probably likely. And it's not just about that people may express them in a different way. It's also that the kind of people who know about this website and are going there already colors the data, right? Because it's a specific demographic. I can almost think like people who have good access to internet, good fluency in English, and so on, right? So especially in an Indian context. I agree. Yeah, I think this is certainly a biased sample. But what I was talking about was even within this biased sample, can we find patterns that generalize to only the users of this platform? Even that is hard. That's what I was trying to say. So even if you look for only the people who are using only this platform, even then we found sort of varied degrees of how people express themselves.
Because I
But
was
your point,
remembering some.
yeah, go
I'm
ahead.
sorry. I'm sorry. Yeah. Please
Go
go
ahead,
on.
yeah.
Oh no, my question was so I mean 2 months ago I was talking to a sad friend. So I mean he was sad because something was happening in his life, and
Right.
I remember myself writing something on WhatsApp, deleting it, writing again, deleting it because I thought that maybe I should talk in a this way. Then I wrote
Right.
the sentence, I
Yeah.
deleted that. Then I wrote something, and then when I was sure that I should send this message, I sent it.
Right.
And there are so many nuances to writing and conversing with people that the final sentence or final conversation might not catch. So I mean we have made so many
That's
edits
true.
in that sentence that
Yeah.
maybe we have not expressed ourselves honestly as we should have in the first attempt.
Yes, that is
So
true. Yeah. And
maybe this data set can be augmented to you know so basically we augment this data set with artificial insertions that this is what the data set should have looked like, but this person has not mentioned it, this person has
Mhm.
just deleted it or does not want to talk about it. I mean just an
Yeah.
idea.
Yeah. And I think uh, it may be also possible. I think if you have a smaller set of people, that we may have access to, let's say, general social media and then this platform, right, for the same person. So
Exactly.
that can also give us an idea of how much language changes in
Exactly. Exactly.
in
Yeah.
this.
Yeah.
That's true. Yeah, that's
Yeah.
actually. So there have been some studies that people have done on Reddit and Twitter, but I think even they suffer from the same issue, that they're only looking at Reddit users' activity in a particular mental health forum. But I think comparing them would be interesting, as you said.
Yeah.
There's actually a second application. I won't get time today, but I just want to mention that writing suggestions is itself a big application where I believe NLP can help, but I think we don't have good answers yet. So what I mean by
Yeah.
that is, suppose you are a supporter on this platform, right? And someone posts a message. You have very good intentions to help them, right? And you would write something that you believe will help this person, but does it really help them, right? And
Yeah.
that is complex. It's very hard to predict, of course, but it also depends on where that person, the seeker, is coming from. What have they actually asked? Are they looking for resources? Are they looking for emotional help, right? And so we've tried to do this a little bit with what I described, in the sense of, can you predict what kinds of features in a response help?
Yeah.
And if we can get to a stage where we are confident, then you can imagine writing suggestions. So imagine that someone writes a response, and there might be a tool that says, hey, this response seems too rude. Perhaps you
Yeah.
want to make it more polite to this user. Or, hey, this
Yes. Yes.
response seems to be too much on the informational side, and this person is looking for emotional support, not
Yeah.
informational support.
Yeah.
So we're not there yet, but I think what you said made me think about this application, which could be really useful for people.
Yes, sir.
Any other questions?
So what was the human annotation scale which you mentioned on the previous slide?
Oh, okay. Let me go back to that. Yeah, the scheme here was.
Yeah, this one.
Yeah. So the scheme here was very simple. People would be shown these posts, and what they have to do is just rate the sentiment of the particular post. And behind the scenes, what we were doing was that we would take a thread of these posts, let's say seeker, then responder, and then seeker again, and then look at the sentiment rated by people for each of these posts and check whether the sentiment changed or not. So we did this consciously. We didn't want the raters to have a much complicated task. So rather than asking the raters, hey, whether this was a positive conversation, we just asked the raters to rate the sentiment of a single individual posts, and then we post process it to find out which threads had a positive change.
Okay, so can we model this into a reinforcement learning model, like in whether the goal has been reached or not, like the positive rating has achieved or not? Can we do something like this?
Yes.
Like,
Yeah. So if you're
possible?
doing it in real time, yes. Yeah. So this study that I'm describing to you, we had a data set, and we were kind of doing it after the fact and trying to predict. But you're right. I think if you're doing it in real time, you can imagine a system which is learning from the different responses that people are giving. And especially in the writing suggestions one, this can be very fruitful. So like imagine a seeker posts a response, one
sir.
responder posts something, and we just realized that did not help, right?
Yes, sir.
So now how should the
Even
second responder respond? And that I think you can use policies to optimize that.
or even though we can use reinforcement learning just to track where is the conversation going on, like if the
Yeah.
rating is decreasing, if the conversation is not going the right way, or if it's increasing, how it is increasing, so that can be modeled, I guess, to improve the system, maybe.
Yes. Yeah. I think the only thing I'll caution against is that we still don't know enough about this environment to talk in reinforcement learning language, right? So reinforcement learning typically works well where you can define sort of the rewards and the sort of features in a much more principled way. Here, I would say we are still in the infancies of making those reward functions correct and also understanding like what are good outcomes. So for example, here I use this very crude measure of change in sentiment. But as I said, it doesn't capture all of the good responses. It doesn't capture all of the good interactions. So we just have to be careful. I think RL can be applied, but you have to be careful that just optimizing a metric like this may not be enough. I think we have to do sort of innovate on both parts, like innovating on the measurement, which is the reward function, as well as the policy.
Okay, thank you, sir.
Great. I'll move on to the second part. So this part, think of it as more operational. One part that we can help with is data science, but then there's also a bigger chunk of people who are not even aware of these apps and probably don't have access to it because these apps are all English and on the internet. So I've been talking to and working with NIMHANS, which is a mental health institution in Bangalore. And one of my collaborators, Dr. Seema Mehrotra, says that people often take a long, circuitous route to ultimately reach us and seek counseling. And perhaps this is because there's fear and stigma, even about admitting that you may have a mental health condition or an issue, and you may want to go to a counselor, right, or a therapist. So we thought about how to increase awareness about mental health at the same time not mentioning mental health. Now you understand the catch-22, right? Even though there are very few psychologists in India, I think that's also true. But what we are hearing from the psychologists is that even they can handle more people and they would want more people to come to them early. But what happens is that even the people who are coming to them are saying things like, oh, I took 1 year or I took 1 to 2 years to try everything else before I actually thought of coming to you. So the question here is how to encourage people to speak out and seek help, but at the same time be mindful that there is a stigma in our society. So Dr. Seema actually did a study first on trying to understand what are people's barriers to seeking help. And when you read through these lists, some of them would immediately probably resonate with you. People may think that counseling will make them weak or make them considered weak by others. They may affect retribution from job, from their family. They may think that it's not a problem, like it's just something that may go away. And sometimes they just don't believe that it can be like helped by therapy. One common misconception often is that therapy is just like talking. I can just talk for free with anyone. So perhaps why would I need something to pay for or for being a professional help? Anyways, so I just wanted to mention all these because many of these actually are impeding people from reaching out, which means that as simple as even if there's an app available, right? Let's say there's an app available for mental health, and let's say that it's magical, like it'll just solve. There's nothing like this exists, but I'm just saying it as a thought experiment. Suppose there's a magical app that exists. Even then, people may not use that app because they might think of many of these things that I just mentioned. So we thought about what can we create that helps people actually cross these barriers and encourage them to talk to a real person? So in our case, it's a therapist, but you can also imagine peer support acting in a similar way, that you want more people to come to Talk Life. But how do you increase awareness about Talk Life in a way that people are willing to use it? So we came up with this basically like two-step architecture. The first is that we have to focus on breaking these barriers. So we have to focus on how we can help people sort of just reframe whatever concerns they have and present them alternative information. And the second was self-discovery. We also want to enable people to learn about themselves as well. Because you might be feeling low, sad, anxious, but you may not be understanding exactly what is going on. So with that, we thought that let's create an app, because none of like that exists. Most apps today that exist focus on self-help, which means that you can get many techniques and tricks to sort of have a good habit routine, work on yourself, and so on. But none exists to actually break your barriers to seek help. This is what we have created today, and it's now under testing, and I think should be out on the Play Store soon. This will be a free app. It's from Nimhans, the organization, and we are working with them on building this app and also looking at how we can build interesting, intelligent features in the app so that it can help others. If you're interested in trying it out and giving us feedback, I mean, just send me an email. I'm happy to connect to you. But more broadly, also, the way we are looking at it is like a research project where we are trying to build something that we believe from research should be useful for people with mental health concerns. And then we want to actually deploy the app and learn whether that actually helps people or not. And of course, from those learnings, we'll also learn more about what kinds of technologies can be useful. How much time do I have, Saket?
15 minutes at least, but you can take 20 minutes. It's perfectly fine. Go at your
Okay.
pace.
Okay,
no hurry.
Sure. Okay. So with these two, right? So I've given you a flavor of what we can do on the online space, which is global, and it, as one of the commentators pointed out, it still is a colored view. It still is a very specific sample, but it's broad. It's sort of global audience, and then people, especially the people who can access the internet and are online. The second project I showed you was about people who had phones and perhaps could talk in a local regional language, not just English, but any language like Hindi, Kannada, Telugu, and so on. So those people can now access the same kind of resources. And they can also look at how to break some barriers to seek help. The third part I want to point out is probably the part that would affect most people, but is also in some sense the most neglected. And what do I mean by that? So in India, there exist mental health helplines, which means that there are crisis helplines. There are also counseling helplines, which means that if you're not feeling well, and let's say you are at home, what do, right? So one answer is if you know about these websites, you can browse them, but that's unlikely. If you had a phone and you had access to some good apps, you would probably use them. But after a point, you would realize that those apps also are just not that useful, because then you're not talking to anyone, right? You're just sort of working with an app. So what happens is, for most people, helplines are a way to actually reach out to someone real and as someone human being on the other end, talk about their problem, and hopefully if the helpline is good, that helpline actually gives them either advice or sort of sometimes they just listen to them and give them this reassurance that someone is there who's listening to them. But what's happening in India is that those helplines are underfunded, and there have been reports by journalists where, for example, this journalist tried 40 calls to all the available helplines in India, and I think they found like maybe only 6 of them worked, or some small number like that. So what it meant was that nobody was answering these helplines. And that's kind of one of the worst things that can happen,
Like you're already feeling down, you're already feeling that there's not a lot of hope. And when you call this one number that is supposed to help you, that number also responds with nothing, no response. So this was something that we understood, that if we really had to help the mental health landscape in India, we cannot ignore helplines. Like apps are good, websites are good. I think they're useful, but there's still a large fraction of people for whom the only way is helplines. And especially because now helplines can connect you to a semi-trained counselor, which can scale very well. So what do we do? So what we did was we talked to people who were running helplines. I'm giving you some examples here. Maitri is one, Sahai is another one, Kuch is one. And then finally, we found out that there's an organization called Befrienders India, which is helping coordinate many of the helplines that run in India. What we found was that these helplines are filled with volunteers who are well-intentioned and they want to help. But the challenge is that, one, the volunteers don't work 24 hours, obviously, right? So there are shifts, and then many of the shifts are unattended. So there's no volunteer. And that's the reason why the probability is that if you call a random helpline, no one would be available. The second we found was that they were facing unique challenges because of COVID-19. Many reasons, but I think mostly because they did not have such a good technological infrastructure. So they had landline phones that you had to go to be able to run the helpline. So what we first tried to do was to understand what may be the issues of these helplines. And we did a paper which was interview based, where we interviewed the volunteers of these helplines, and we asked them for sort of what is the kind of technology you would hope for? What is the best sort of system you would want? And based on that, we have now started a pilot in Kerala, where what we did was that we said, let's all these helplines run, but let's connect them through a single number so that one, users don't have to remember so many numbers. So as a person, I just need to remember one number. And at the back end, we can do intelligent routing to route the numbers call to whichever helpline is available right now, maybe whichever helpline speaks the same language as the person, and so on. So you can do intelligent routing at the back end. But at this point, what we've started with is a pilot in Kerala, where everyone speaks Malayalam or English. But we are focusing on availability. So we are checking out if you dial onto a single number and you can route to different centers automatically, does it actually increase the access to these helplines? And the way we are thinking of it is, one, again, that it's going to increase access and we can perhaps add more numbers now. So let's say if it works in Kerala, we can add helplines in Maharashtra and so on. So you can increase the scope to entire India. And the second is that it's also helping us understand to what extent helplines can actually help people with their mental health as well, right? Because one of the things that has happened is that there's not enough research done on the efficacy. So how good are helplines versus an app? Or how good is, I don't know, like going to a clinical psychologist at NIMHANS? Of course, that's good, but if that's not available, then would helplines help? So those kinds of questions are not yet well answered, primarily because there's no data. So one of the things we are hoping for is, once these kinds of helplines are available that are technologically routed, we'll also start collecting useful data about when people call, how long these calls are, with privacy restrictions on what kinds of topics are being talked about and in what cases it's successful. And as a side goal, we are maintaining an up-to-date list of all helplines in India. So this was also another one of these things where we started with a research question, but we found that there's something pretty much very practical we can do, because nobody is actually maintaining a full list of all helplines. And so we just did that on our webpage. To conclude, I hope I gave you a broad brush on what are the key challenges in mental health today and how technology
can be useful in a sense to just augment the capabilities of people who are already working in the domain. And I gave examples of online systems, apps, and also helplines, where we can improve access to mental health resources and also in some cases help few experts to reach a broader population, especially outside the big cities. If you're interested, you can check out our project. There's a link that I'm sharing here, but you can also just search for Moments of Change at Microsoft India. You'll find a list of the papers that we have done and also some of the collaborators that we have. And at this point, I'd be happy to take more questions. Thank you.
Thanks, Amit. So now the floor is open for questions from people. So please go ahead and ask question to Amit.
Okay. Sir, what are the currently open projects in this moment of change thing?
So currently, I think, as I mentioned, we are working on the app with Nimhans. So that's the main project that we are focusing on. And separately, there's also a question of how the same technology can be useful in different contexts. So for example, how would it be useful on the web versus how would it be useful inside the workplace, for example. So I think the main project that we are currently working on is with Nimhans on building this technology and then looking at the data that comes out.
Okay, sir.
So,
Yeah.
so for example, you mentioned that there is no data to see the efficacy of the helplines. However, how would such data be collected? For example, if a person were to use a particular helpline and then go on to seek therapy from a psychiatrist, would that be considered that the helpline did not help the person enough, or would that be considered a positive that the helpline was capable enough to generate awareness to have the person seek professional help?
I think it'd be a positive, the second thing that you mentioned. Yeah. So, but what the question that you've asked is a great one. So give me a minute. I think I can try to answer it. It's one of the questions that I don't know the answer to. And we are trying to figure out on what would be the good way to measure it. So the challenge is not just that there are sort of different pathways. So helplines are one, clinical psychologist is one. It's also that it's a very sensitive domain. So any kind of data collection that we do has to be privacy preserving and has to be with the consent of the caller. Because the last thing you want is a reputation of a helpline that it will record everything that you say, or it will kind of try to use you as data for whatever research that we want to do. So that's number one. So I think we have to be very careful about privacy. And the second is that if you do that, then how do you measure utility, right? So we cannot also just actually call people and ask whether the call was helpful or not, because often people would find of that irritating, of course, but also we have to remember that you might have called at some vulnerable time. And when this call comes, it may come at some other time where you're with other people. And you typically not want people to know that you've been calling this helpline, right? So with that in mind, I think the kind of metrics we are looking at are, some of them are just correlational, like how much time you're talking, whether you're calling again or not. And then we are looking at innovative ways of asking people on the call itself, probably not by the same counselor, but probably by the system itself. Like once the call ends, maybe there's a system prompt that asks that, was this call useful? Or would you sort of think that you would call again? Those kinds of things we are exploring. But definitely, I think, yeah, so the referral part is definitely a plus. So if a helpline helps you get connected to more resources, that's definitely a good thing. I think, yeah, because no one believes, I think, yeah, we won't believe that helplines are the answer. I think helplines may be the answer in some crisis situations, but often if a situation is complicated enough, referrals is, or not even referrals, I think just connecting people to more resources itself could be a useful outcome of calling a helpline.
Thank you, sir.
Great. Maybe one more question. If someone has it in the mind, please go ahead.
Yeah, so I wanted to ask again about this privacy issues, which you already touched upon.
Right.
Given so much privacy issues in online and social media, I would think that the data you will get will be very, very scarce, because people may, the proportion of people who even come to online or even calls will be much, much smaller than people who are actually having problems, right?
Yes, that is true.
Yeah. So you mentioned about anonymous conversations and so on, right? And initially.
Yeah.
I mean, would people really come there? Because it's, how much can you trust that it is anonymous, right?
Yeah, no, that's a good question. I think there are two parts of the answer to that. So one is, I think what is happening is that the situation is so bad, like that youngsters are willing to take that bet in a way. I think probably because if they probably can't talk to their parents about it, or they have tried to talk and it didn't work out. They are probably at some university or somewhere where those resources are not available. And I think probably what's mattering more is that they're already used to using apps for many things, and they're already sharing a lot. So maybe I think for that reason, the young generation is also going a lot on these kinds of forums and maybe expressing themselves. For a person like me, it's still I'm still surprised that Talk Life can work. Like the fact that you can post something anonymously and some other anonymous person helps you is itself a miracle to me. But I think somehow it's working. So that's the first part to your answer. I think I would be skeptical if sort of a lot of people were using this, but I think it's primarily the younger generation. I think that they're just taking up the apps and other kinds of things much more openly.
Yeah, I guess the easy access compared to reaching out to somebody helps here, because here they just have to go on and key in and went out.
Yeah, exactly. Yeah. But on the other hand, though, I fully agree with you. I think if you really have to understand the challenges and understand sort of the population level mental health, we have to move beyond sort of the social media and look at things like probably helplines is the best answer that I have today. But I don't know. But I think, yeah, we really have to look at sort of all the different kinds of access points and look at what kinds of even topics are coming about. Because one thing we also have to realize is that mental health is not just about like a particular person and helping them, right? If there's a common topic, like let's say the common topic is stress during exams, then perhaps we have to do something about that as well, right? And not just sort of help the single person. But even there are now these challenges. So if you look at Talk Life, most of the content I would say is about either relationships or like academic work performance, like sort of success, let's say, right? So professional success. On the other hand, if you look at helplines, the distribution is different. Relationship still is one of the key factors, but then there are many. Financial is a big one. So in helplines, often people call because there are financial trouble, which is a long-term financial trouble, and that is affecting their mental health. And so I think even those parts show you that there's more there. And I think any one platform cannot capture all the issues. Cool. Okay. Thank you. I hope this was useful.
Thanks, Amit, for such a wonderful talk. And I hope the participants and everybody else have enjoyed it. Thanks again for accepting our invitation and giving a talk. So with that, I conclude this session. So let's come again at 2:30 for the last two lectures of the session. Bye-bye. Have a good lunch.
Okay. Thank you. Bye.
Thank you, sir.